Integrate the following with respect to x, showing all working. Now we've got 4 integrals to do in this question. I was quite lenient with this in the marking, but bear in mind that that may not be the case in an external exam. So here we have that u is 2 plus cos squared x. So du dx is going to be 2 cos x multiplied by the differential of the inside, so that's negative sine x. So du dx is negative 2 sine x cos x. Now, 2 sine x cos x, I know, is sine 2x. So we've got minus du is equal to sine 2x dx. So the sine 2x dx can replace these things here. So we can now rewrite the integral as minus the integral of 1 over u squared du. So that's minus the integral of u to the negative 2 du, which is minus u to the negative 1 over negative 1 plus a constant. So that's just 1 over u plus a constant, and u was this, so that's 1 over 2 plus cos squared x plus a constant. Now this one's actually quite easy if you go about it the right way. Note there's 3 marks. So just an answer cannot get you all 3 of those marks. I awarded 2 for the answer, but I reckon that in waste they would only award 1. So beware. So using index laws, this is e to the x cubed plus x. Then note that this is f dashed x if this one is f of x. And I mean there just the x cubed plus x. Now the integral of f dashed x e to the f of x is always just e to the f of x plus a constant. So our integral is going to be e to the x cubed plus x plus a constant. So now we want to do this integral here with this substitution. Now the first thing to note is if u is x plus 1, that means that x is equal to u minus 1. Du dx here is just 1, and that means that du is equal to dx. So our integral can become the integral of u minus 1 times the square root of u, which remember is u to the half, du. Now if we expand out the bracket, remember this is u to the 1, so that's u to the 3 over 2, take away u to the half, du. So that's u to the 5 over 2, 2/5 of, u to the 3 over 2, 2/3 of. Remember we divide by the new power, but since it's a fraction, turn upside down and multiply. Add a constant. So that's going to be 2/5 of x plus 1 to the 5 over 2. Take away 2/3 of x plus 1 to the 3 over 2. Add a constant. Now once again with this one, note the 3 marks. If you don't show working, you can't have all 3 marks. In waste you'd probably only get 1 of them. I gave 2 because we haven't stressed this before, but bear in mind you'll never get that sort of leniency again. So what we have here is integral from 0 to 5 of 4x cubed plus x squared over 3x to the 4 plus x cubed plus 9. Now think about differentiating 3x to the 4 plus x cubed plus 9. That's 12x cubed plus 3x squared, which is actually 3 lots of 4x cubed plus x squared. So what we actually have here is 1/3 of the integral from 0 to 5 of 12x cubed plus 3x squared over 3x to the 4 plus x cubed plus 9. That's an integral of the form f dashed x over f of x. So we know that's going to be 1/3 ln 3x to the 4 plus x cubed plus 9 to be evaluated from 0 to 5. So that's 1/3 ln. So now we just need to use the calculator. So 3 times 5 to the 4, add 5 cubed, add 9 is 2009, and then if we put 0 in there, that is 1/3 ln 9, and we could write that neatly as 1/3 ln 2009 divided by 9, or you could give a calculator answer.